continuing on with section 5.4. If you recall on Friday we worked on solving equations, getting rid of e's by taking the ln of e's, getting rid of ln's by taking the e's. Do you recall this on Friday? Yes. Remember how you all sat very quietly and worked most of the hour? Do you remember that day?
Yeah, that was like the best day.
I do remember that day very well too.
I wasn't here.
It was because the lights were off. That's why.
So 5.4, we are moving on with exponentials and logarithms, but today what we're going to do is find the derivatives of e's. The derivatives of e's, that is the goal of our notes today. Not long, and actually not very hard either, so I think you will enjoy this. Maybe not enjoy it, but since x squared times x to the 4th power is equal to x to the 6th power, what is e to the 4th power times e to the 3rd power?
E to the 7th.
It is e to the 7th power, which just means that if you have e to some power and you multiply it by e to some other power, you are going to get e to the power of those two powers added together. E to some power plus e, or times e to some power, the e's are the same base value, and since it's the same base value, all you have to do is just add the exponents together. Okay? Alright, this is kind of review of old stuff, but I wanted to make sure that you understood that translates into e's as well. Okay, the derivative of e to the x power. So the derivative of e to the u power is equal to e to the u times the derivative of u. So if you have e to some power, all you have to do is rewrite whatever it is, e to whatever power, and then you multiply that by the derivative of the power. It's really that easy. If you have the natural log of u, do you remember the natural log of u? What was the derivative of the natural log of u?
U prime over u.
It was u prime over u. So if you have e to some power, it is that function. Notice, kind of like over here, that function went on the bottom. In this case, it's going to just be multiplied by the derivative of the power instead of the derivative divided by the actual function. So, all right, let's look at an example. Are you guys good with this?
What is that? D over dx?
D over dx. That just is notation for finding the derivative of e to some power. Okay. D over dx, the derivative of e to the u is equal to e to the u times the derivative of u. All right, example. F of x is equal to e to the 2x power. So the derivative of this is going to be this whole thing, e to the 2x, multiplied by the derivative of the power. What is the derivative of 2x?
2.
It is 2. So the derivative of e to the power of 2x is 2e to the 2x power. Easy?
For now.
That's the answer? That's it. Yes, really. E to the 2x plus 1 power. The derivative is this thing, this e to the power of 2x plus 1, multiplied by the derivative of 2x plus 1. That's 2. Which is equal to 2e to the power of
2x plus 1.
2x plus 1.
Sorry.
That's okay. The next example is e to the negative 3 over x power. So I need to, the derivative of this means you rewrite the original function. So the derivative of f of x is equal to e to the power of negative 3 over x, and then we have to multiply that by the derivative of negative 3 over x. So we got to figure out what that is. So what I'm going to do is come down here and just do a little bit of scratch work. We have negative 3 over x. That is the same thing as negative 3x to the negative 1.
Mm-hmm.
All right, so what's the derivative of that? 3x to the negative 2 power. Yeah, would you agree? Okay, which is what? 3 over x squared. So this is the derivative of our power that we have right here. So I'm going to take this and multiply it by the original function. So it's multiplied by 3 over x squared. And then we're going to rewrite this as 3e to the negative 3 over x power, all divided by x squared. What is wrong with what I have?
Negative.
Negative exponent. And that would be a real quick, easy fix. You could just take this and just move it down to the bottom next to the x squared. So this is the same thing as 3 over e to the power of 3 over x multiplied by x squared. Say that one more time. Would I accept this answer? Is that what you're asking me? Instead of this one? I would say because this is a quickie, I would expect you to take it a step further. If you didn't, you'd lose a half a point or something. But let's say that in the numerator, however the derivative worked out, let's say that the numerator had a 3 plus e to the power of negative 3 over x. Do you see how this negative exponent, it would be much more difficult to move it to the bottom because of that plus sign in between it? I would say if you end up with a situation like that, don't worry about moving that negative exponent to the bottom, just leave it as is. Okay? I think that is going to happen at some point in one of your assignments. So, all right, I think I have one more. I do have one more. This is a good example. We really should go over this one. F of x is equal to x times e to the x. You have to find the derivative. Yeah, someone just said product rule. Good for whoever said that. Do you see the product rule here? Yep, you've got x times e to the x power. That's two different functions, so we have to use the product rule. So the product rule, let me refresh your memory quickly, is the first function, so in other words, the x times the derivative of e to the x power plus e to the x times the derivative of x. All right, so the derivative of f of x is going to be x times, what is the derivative of e to the x power? E to the x power multiplied by the derivative of the power. What is the derivative of the power of x?
1.
It is 1. So I'm going to put the 1 there. You obviously don't need to, but I want to have it there just so if you look back to it, you're not wondering why I didn't multiply by the derivative of the power, because I did. Plus what? E to the x. The second part stays the same now. And we have to multiply by the derivative of the first part, the first function. What is the derivative of x? It is 1. So this, x times 1 is x, e to the power of x, plus e to the power of x. how we write it. Well, oh, okay, you know what, let's do that. That's a good question, because the very, you know what, in fact, I should have, let's do that, let's add to this, we'll add to this, what is the, Tram, put a zero, if you put a zero in for the x's here, 0 is 1, okay, let's do this. Find the slope. I think I have it. Find the slope. I'm making this up on the fly. I just want to make sure it works out okay. Find, not the slope, find the equation of the tangent line at 0,
1.
0, 1. All right, so to write the equation of a tangent line, you need a slope and you need a y-intercept. I think this will come back to you pretty quickly. The slope. This is the formula. Remember the first derivative? That's the formula that you use to find the slope. This is your slope formula. So let's find the slope at 0, 1 of using that first derivative. So the slope at 0, 1, that just means that you have to replace the x's in your slope formula with a 0. So you're going to have 0 times e to the 0 plus e to the 0. Well, 0 times anything is 0, so that has no value. And then e to the 0 power is 1. So you have 0 plus 1. So the slope at 0, 1 is 1. And then do you know what comes next? Very nice. Y equals mx plus b. The first derivative is representation of the slope of the tangent line. Yep.
So what did you do with the slope?
This is the form. This derivative. So this first derivative is like the formula that you can use to find the slope. So I gave you a point, 0, 1, and I said, what is the slope at that point? So you take just the x value of that point and you plug it in for all the x's into your first derivative. And when I did that, I ended up with 1. So I know at the point 0, 1, the slope is 1. All right, and now I'm going to figure out the whole equation of my line. Y equals mx plus b. What is the y value?
1.
Y value is 1. The slope is 1. What's the x value? It is 0 plus b. Well, that's nothing. So what's b? 1. B equals 1. So the equation of the tangent line is going to be y equals 1x plus 1. So I'm just going to write x plus 1. Thank you, Sean, for mentioning that, because I did not remember that in my notes, and it does show up in your assignment. In fact, I think the first 4 questions maybe ask you to do that. So the equation of the tangent line would be x plus 1, y equals x plus 1. All right? Okay. Your job is to do 5, 4, 1. It's already on the board. 33 through 46.